class, this is the pre-lecture for Chapter 2 Thermochemistry. We are going to learn about these 4 topics. First, we must know what is the concept of enthalpy. So we need to know how to explain the endo or exothermic reaction by using the energy profile diagram. This one you have learned already in Chapter 1. Then we must state what is enthalpy and what is standard enthalpy. And then number 3, you need to define and write thermochemical equation for each of the following enthalpies. So we are going to look it one by one. You have to, here you have to take those solution actually equal to this solution as well. Don't be confused. So what happened to the ice cream and the hot coffee after 10 minutes? After 10 minutes, the ice cream no longer ice cream. It will not become liquid. And then the hot water become room temperature. So why the temperature will decrease or increase after 10 minutes? So we have to know certain important terms. First is about heat. Heat actually is the energy transfer between two bodies of different temperature. Okay, maybe A with 60 degrees Celsius and then B with 20 degrees Celsius. So the heat for 60 degrees Celsius will transfer to 20 degrees Celsius. So 60 degrees Celsius decrease and then 20 degrees Celsius increase. So this means by energy transfer. System is any specific part of the universe and surrounding is everything that lies outside the system. So we can say that system plus surrounding actually is equal to the universe. Now, we need to know what is energy. Energy is the ability to do work. The unit is joule. Okay. Then we have to know joule actually equal to kilogram per m square per second. Okay. Normally we use the unit joule or kilojoule, but you have to know there's another form of the unit of joule. Next, older unit is calorie. I think for those who on diet, right, quite familiar with this one because we need to calculate the calorie of chicken, the fried chicken, the rice, the bread, and so on. We have to know 1 calorie actually equal to 4.184 joule. So this is the relationship between calorie and joule. Next, we are going to study the heat change in chemical reaction. And there are 2 types of chemical reaction. The first one is exothermic and then the second one is endothermic. Okay. So exothermic reaction is the reaction with the enthalpy in negative value. The enthalpy is in negative value for exothermic. Why? Because the enthalpy of reactant is higher than enthalpy of product. You just assume. Okay. The value of this one is 2 and then this value is 1. Normally we are using the final minus initial. So 1 minus 2 equal to negative 1. So that's why exothermic reaction is with negative value. Enthalpy is negative. And another meaning is exothermic is heat is released from the system to the surrounding. The reaction, for example, combustion and neutralization is one of the exothermic reaction. So the reaction between hydrogen and oxygen also form water also release heat. That's why this is exothermic. Another reaction is methane. Okay, react completely with oxygen. So this is combustion, and then from carbon dioxide and water, and then heat is released. So you must know combustion under exothermic reaction. Okay, this is the energy profile diagram for exothermic. Okay, as I told you all just now, right, you can put a value 2 here, and then here is 1. So this is the enthalpy of the product. 1 minus 2 equal to negative 1. That's why the value of enthalpy is negative for exothermic reaction. Okay, so just have a quick review. Here is reactant. So you have to write down the reactants over here into the energy profile diagram, and then here is product. Okay, you cannot simply just write out reactant or product in general. You must refer to the equation. If the chemical equation is given, so you must state what is the reactant and then what is the product. And then the enthalpy with the negative value is exothermic reaction. And then the difference between the enthalpy of reactant and the enthalpy of product is enthalpy. So from the top until reactant, we call it as activation energy. If you still remember, last chapter we learned about what is activation energy, and then we learned the method to lower the activation energy. Do you remember what is the method can decrease the activation energy? Yes, the answer is by adding catalyst. Okay, now we go for endothermic reaction is with enthalpy positive. Here is the enthalpy of product higher than the enthalpy of reactant. Heat it absorb. For example, ice melting. So you have to absorb the heat first, then only the ice will melt, become water. And it is the same when the water will be is you continue to heat, it will change to vapor form or gas form. So heat absorb. Endothermic. The energy profile diagram for endothermic. Okay, so here you can put assumption here 1, 2. Now 2 minus 1. 2 minus 1 equal to positive 1. Okay, so the enthalpy is with positive value. Okay, and then from the top until the reactant, right, is the activation energy. Okay. Don't forget the y-axis over here is enthalpy, and then the x-axis is reaction pathway. Okay, we keep on saying enthalpy, enthalpy. Then what is enthalpy? Enthalpy will represent by the symbol of H. It's the heat content or total energy in the system. And then we measure through the heat change. Normally we use the final minus initial. For example, system undergo combustion or ionization. Then we give the heat to the system. There is a heat change when the reaction happens. Next is the summary of enthalpy change. Heat given off or absorbed during a reaction at constant pressure. Heat given off or heat release, this is exothermic process. So the enthalpy of reactant is larger than enthalpy of product. While this case is the enthalpy of product is larger than enthalpy of reactant. So this is endothermic, heat in or heat absorbed. Next, we are going to identify what is the difference between enthalpy of reaction and standard enthalpy of reaction. Enthalpy of reaction, right, is just an enthalpy change associated with chemical reaction. So normally we are using the sum of enthalpy of formation of product minus the sum of enthalpy of formation of reactant. And then if there is a word standard for the enthalpy, the symbol will be a triangle, capital H with the note, okay? So we call it standard enthalpy. So standard enthalpy change for a particular reaction that occur at 298 Kelvin or 25 degrees Celsius and 1 atm. So when we talk about standard enthalpy, we must emphasize on this temperature and this pressure, 298 Kelvin and 1 atm. Okay, there are many kinds of enthalpy we have to learn in this subtopic. So the first one is enthalpy of formation. The heat change when 1 mole of a compound is formed from its element in their most stable at stated temperature and pressure. Most stable state, okay? Most stable state at a temperature and pressure. Okay, so heat change. Heat change meaning that it can be exo or endo. We're not sure it's heat release or heat absorbed. That's why heat change. 1 mole of compound is formed, meaning that this one is referred to product. Okay, it formed from its element. Hydrogen is the element, oxygen is the element, potassium, solid, bromine, molecule. So all of these elements form from element and then at their most stable state. If stable state, right, the enthalpy of hydrogen is equal to 0. Okay, then stated temperature and pressure. If added standard over here, then the condition is 298 Kelvin and pressure 1 atm. Okay, so this is the enthalpy of formation of the element oxygen or element chlorine equal to 0. Next, enthalpy of combustion. Okay, triangle, the symbol means the change of enthalpy combustion C. The heat release, meaning that this reaction is exothermic. So must with negative sign. When 1 mole of substance is burned completely in excess oxygen, it burned completely in excess oxygen. So meaning that this methane or this propane, right, both of them are the limiting reactant. Okay, so in this case, this enthalpy of combustion is referred to reactant and is exothermic reaction because heat release. Next, enthalpy of atomization. Okay, triangle symbol A, and then the heat absorbed. So this is endothermic reaction. When one mole of gaseous atom is formed normally is referred to product from its element, again element, at stated temperature and pressure. So you keep on saying one mole, right? So make sure here is one mole. It's one mole because the definition is referred to one mole. Okay. So the enthalpy with positive sign because it's endothermic. Okay, normally you don't need to state it's one mole. Write down the one. Okay, just like this. Okay, now we go for enthalpy of neutralization. The heat release, again, this is exothermic. When one mole of water is formed, again, is formed means it's referred to the product. From the neutralization of acid and base, you already know in Form 4, the reaction between acid and base we call as neutralization at stated temperature and pressure because just enthalpy. That's why at stated temperature and pressure. Enthalpy of hydration. Okay, this is heat release mean exothermic reaction. When one mole of gaseous ion is hydrated in water at stated temperature and pressure. This hydration, right, is quite new with you all, term hydration. So you have to know is the gaseous ion dissolved means hydrated in water and then from the cation in aqueous form. Okay, we are going to learn this again in 2.4. Okay, enthalpy of hydration. So negative sign because this one is exothermic reaction. Okay, enthalpy of solution also we are going to learn again in chapter 2.4. Heat change when one mole of a substance is dissolved in water. Okay, one mole of substance is referred to the reactant dissolved in water and then form the aqueous ion. So, based on here, right, you can deduce something. What is the relationship between enthalpy solution and enthalpy of hydration? You check. This one is one mole of substance is dissolved in water. Okay, so it's K plus aqueous plus chlorine aqueous. And then this one, okay, also in aqueous form, the product is in aqueous form, but it's gaseous ion dissolved in water from the aqueous ion here. So they are forming the same type of product. Cation aqueous, anion aqueous, here cation aqueous, anion aqueous. Now we go for, okay, the enthalpy of reaction, okay, with the note, means standard. So this is standard enthalpy with the condition 1 atm, 25 degrees Celsius or 298 Kelvin. Standard state with the note is referred to standard state. So, madam, encourage you all do this summary. Okay, so this is one of the definition summary and then the example and then I highlight is referred to reactant or product. Okay, ionization energy, electron affinity, and lattice energy you are going to learn again in 2.4. Okay, the dissolution process. Okay, so this is another summary. So heat change involve enthalpy of formation and enthalpy of solution, meaning that this reaction might be exo or endo. But for enthalpy of atomization, for sure is endothermic because heat absorbed. So there's enthalpy with positive sign. And then this one heat release, okay, so with negative sign is exothermic reaction, which included enthalpy of combustion, enthalpy of hydration, and enthalpy of neutralization. Okay, this is another example summary. So I put here which enthalpy involve reactant, which enthalpy involve product, and then which one is endothermic, which one is exothermic. Always remember, bond breaking, heat absorb. Okay, heat absorb. After heat absorb, right, the enthalpy of product is larger than reactant. Okay, because you need to absorb the heat, then only can form the product. That's why enthalpy of product is higher compared to reactant. Okay, for bond forming, release heat. Okay, release heat. Initially, reactant higher temperature or higher enthalpy. I should say higher enthalpy, not temperature, higher enthalpy. That's why once it's released heat, that's why the enthalpy of the product is lower. Get the concept? Here, so bond forming normally is exothermic reaction because release heat. That's why the enthalpy of the product is lower. Bond breaking absorb heat. The reactant after absorb heat then become the product, then the product share with higher enthalpy. Okay, next about thermochemical equation. Okay, this is the normal equation that we learned before. We call it as chemical equation. But upgrade now you need to mention thermo. Thermo means we need to involve the enthalpy. Okay, positive or negative sign insists. Okay, for example, this one if you write down 6.01 kilojoule per mole, so sorry. Okay, no mark is given for the thermochemical equation because we need to know whether the reaction is endo or exo based on the sign. Okay, so if the question asks you how to explain this equation, the equation is 1 mole of water liquid is formed from 1 mole of H2O solid ice at 0 degrees Celsius. Okay, in this case, just enthalpy, that's why 0 degrees Celsius. And then the enthalpy is positive 6.01 kilojoule. If you reverse the whole equation, actually the value is still the same. Okay, when you reverse the equation, the value is still the same, but now the sign is changed. Once you reverse, the sign from positive change to negative. Okay, however, when 1 mole of ice, H2O ice solid is formed from 1 mole of water, liquid, H2O liquid, the magnitude of the enthalpy remain the same. Magnitude enthalpy remain the same, but you have to change the sign, opposite the sign. Okay, get it? This point is very important. Let's look at one example under this topic. The combustion of a sample of aluminium produced 0.25 mole of aluminium oxide and release 419 kilojoule of heat at standard condition. Meaning that, okay, we have to write an equation which is under enthalpy of combustion. So 1 mole of aluminium react with excess oxygen and then form half mole of aluminium oxide. Over here is 0.25 mole of aluminium oxide is produced with 419 kilojoule. Okay, now the question asks calculate the standard enthalpy of combustion of aluminium. Okay, refer to here. Okay, the standard enthalpy of aluminium combustion produce half mole of aluminium oxide. The information given by the question is 0.25 mole. That's why we need to perform the calculation by stoichiometry. 0.25 mole equal to 419 kilojoule. How about 0.5? You stoichiometry 0.5 times 419 over 0.25, then you will get 838 kilojoule. So meaning that the enthalpy, standard enthalpy of combustion of aluminium. Okay, this one, the 1 mole of aluminium is equivalent to 0.5 aluminium oxide. That's why the enthalpy release, right, we can calculate based on the mole of aluminium oxide. So the enthalpy for combustion of aluminium is negative 838 kilojoule per mole. If you notice, right, when we perform the calculation, the negative sign is not here. But since you know the definition of combustion is heat release, and then it's an exothermic reaction, that's why when you make the conclusion must be negative. And then the standard enthalpy is referred to 1 mole. That's why the final unit is kilojoule per mole. Kilojoule per mole insists. Okay, so enthalpy of combustion of aluminium heat release when 1 mole of aluminium is completely in excess oxygen at 298 Kelvin and 1 atm. So this is the definition of standard enthalpy of combustion based on this equation. Okay, second question, determine the enthalpy of formation of aluminium oxide and write its thermochemical equation. Over here is referred to formation of aluminium oxide, meaning that you have to make sure that the number of mole for aluminium oxide is 1 mole. Okay, so actually very simple because half mole equal to 838. If you want to change it become 1 mole, just times 2. Okay, let's check the answer. Yes, you just times 2. 2 times negative 838. So you get the answer negative 168 times 10 to the power of 3 kilojoule per mole. So enthalpy of formation aluminium is the heat change when 1 mole of aluminium oxide is formed from its element. What is the element? Aluminium, solid, and oxygen gas in their most stable state at 298 Kelvin and 1 atm. How about thermochemical equation? So now, because it's referred to 1 mole of aluminium oxide, that's why we need to times 2. Okay, over here we times 2. Okay, over here we times 2, meaning that the whole equation we need to times 2 as well. So the whole equation times 2, that's why it becomes 2 mole, 3 over 2 oxygen gas, and then for 1 mole of, the 1 mole is referred 1 mole of aluminium oxide solid. Don't forget you must show the enthalpy with negative 1.68 times 10 to the power of 3 kilojoule per mole. Okay, balance equation is very important. Phase insists over here, insists over here, and then the enthalpy have to write down as well, and then must with the negative symbol is referred to exothermic reaction.